There's a tiny chip that's been run for more than 50 years and has been used in many electronic circuits like LED flashers, generating time delays, motor controllers, LED flashers, and many more. And yes, you guessed it right. This is 555 timer IC. Now the bipolar 555 IC is operating in three modes. The first one is monostable mode, second one is astable mode, and the third one is bistable mode. And I will cover all of these three modes in three separate videos, right? So this is video number one. So basically there are two types of 555 timer ICs available in the market. Okay? The first one is the bipolar 555, which is the classic one, and the second one is the CMOS version 555. But in this video, I will cover only bipolar 555. Now let's discuss the pinout of this 555 timer IC. So there are total of 8 pins, 4 on right side and 4 on left side. And notice one small semi-circle cut here at the top in this diagram. So the top pin to the right of this cut is a VCC, this one is a VCC, and the pin to the left of this cut is the ground. And we connect these VCC and the ground directly to the power supply, and you can provide the voltage from 4.5 to 16 volt on these pins. Now coming on to the trigger and the threshold pin. So this second pin is a trigger pin and this one is a threshold pin. So whenever the voltage on the trigger pin is low, now low doesn't necessarily means it is 0 volt. It simply means the voltage is less than 1/3 of supply voltage. So in this condition the output is high. So whatever the load is connected to the output pin, which is this third pin, it turns on and it remains in the on condition until the threshold voltage is high. Now again, high doesn't mean it is VCC. It simply means the voltage is greater than 2/3 of supply voltage. And whenever the voltage on the threshold pin drops below 2/3 of VCC, the output turns low. And whatever the load is connected to this pin, it turns off. Now one interesting point to note about the output pin is that it can only source up to 200 milliamps of current to the device which is connected to the output pin. Now sourcing means supplying the current, right? So if you want to use power hungry devices, it is recommended to use either MOSFET or transistors. Talking about the reset pin, this pin can be used in case of emergency situations. So whenever the voltage at this pin is close to or equal to 0, the output goes low. So you can connect a safety switch to this pin to turn the load off. And if you don't want to use a safety switch to this pin, you can simply connect it to VCC. Have you ever thought of this bar which is mentioned over the reset pin? What does this actually mean? So let me make you understand about it. So you need to first understand that there are two types of pin in electronics. First one is a control input pin and second one the data output pin. So if the bar is mentioned over the input pin, it means the pin is active low. And if it is mentioned over the output pin, it means inverted output. So the reset pin on the 555 IC is the control input pin. So it is active low. Now active low means the intended function written on that pin in the data sheet works. It means it is turned on, the function is turned on whenever the voltage is 0 volt on that pin. Otherwise, if you don't want to use the function on the pin, you can connect the pin to the VCC using a pull-up resistor. And for the non-inverted output pins, high means 1 and low means 0. But for the inverted output pins, the logic just get flipped. High means 0 and low means 1. Right? So the logic that is driving the output pin just get flipped inside the chip before it reaches the pin. Now in monostable and astable modes, we connect a capacitor to the discharge pin, also known as timing capacitor. And the value of this capacitor determines how long the output remains high. And when this capacitor charges to 2/3 of VCC, the threshold pin goes high. And we all know that whenever the threshold pin goes high, the output goes low. And in bistable mode, we generally left the discharge pin disconnected. Now you might think that why are you talking about only 1/3 and 2/3 of VCC, not any other ratio? So the reason is very simple. If you see in the circuit diagram of the 555 timer IC, there are 3 resistors connected in series, right? Across VCC and the ground. And each of them are of the same value, 5 kilo. And from this value, the IC has got its name, 555, right? Because of 5 kilo. So they are forming the voltage divider. So one of the intermediate points, the voltage will be 1/3 of VCC, and obviously at the other end, it will be 2/3 of VCC. Talking about the remaining pin of this IC, the control pin. So this pin is used to vary the ratio 1/3 of VCC and 2/3 of VCC by providing the external voltage on this pin. So by varying this ratio, we can vary the timing of the 555 timer IC. And for basic circuit, it is totally optional. Now in the monostable mode of the 555 IC, the output pin has only one stable state, and that state is low by default. Now when the trigger pin is pulled low, the output pin goes high, and this high state is a temporary state, only remains for a definite interval of time. Now the timing capacitor starts charging to a resistor, and once it reaches 2/3 of VCC, the threshold pin goes high, and we all know that when threshold pin goes high, the output pin again goes low. Now you can see the circuit connections for monostable mode of 555 IC. And note that the semicircle cut is on the left hand side, this one, right? And this push button is used to pull the trigger pin low. So one leg is connected to on the ground and other is connected to the trigger pin, the second pin. and this LED is connected to the output pin, the third pin. Okay, and I have already told you that you can connect the control pin which is present at the bottom to the ground using a small capacitor. So this is a 1 microfarad capacitor, and there are two main components in this entire circuit, this resistor and this is a capacitor, also known as timing capacitor. So this resistor is connected to the discharge pin and this capacitor is connected to the threshold pin. Now let me press the push button and you will notice that the LED remains on for a definite interval of time, and you can change this on duration by varying the resistance and the capacitance. So now let me use a higher capacitor. So this was a 100 microfarad capacitor and this is 220 microfarad, and you will observe that the on duration of the LED will increase slightly, right? So the timing of the on duration of the LED is given by this formula, T is equal to 1.1 multiplied by the resistance multiplied by the capacitance. And you can also vary the resistance keeping the capacitance same. Now let me explain you a very important observation here. See, whenever you are using any kind of IC in your circuit, right? I am using this 555. So the use of decoupling capacitor of small value is generally a good practice, because sometimes what happens, the electrical circuit may produce electrical noise and that may affect the internal working of the IC, right? So this decoupling capacitor provide a safe path for that noise to dissipate. So this capacitor is connected across the VCC and the ground very close to the IC. So I'm going to connect this decoupling capacitor across the ground pin and the VCC pin. So the value of this capacitor is 0.1 microfarad and it is of ceramic type. Now I'm going to press the button, but you won't see any difference because the circuit is very basic. The difference becomes significant whenever you are using more ICs or microcontrollers in your circuit. So let me know in the comment section what you think did you learn about the 555 timer IC. And if you enjoyed this video, don't forget to like the video and subscribe to my channel so that the next video could reach you soon. And thanks for watching it.